That one's called Missile Alert. Ratios and proportions, scale drawings, and scale factors. So before we go into this, I want you to see this picture. This is a drawing of a floor plan of a house. Now, here's my question. This is my hand. This is the drawing of the house. Is the actual house the same size as my hand? Or is this drawing smaller than the actual house? Well, it's smaller than the actual house. This is saying that this is a 2,000 square foot house. The actual size of this thing is, this would be 36 feet in this direction and 56 feet in this direction. But the whole house has been shrunk down to fit on a piece of paper. So according to this drawing, 1/8 of an inch, so one little tiny 1/8 of an inch actually represents a 1 foot in real life. So 1/8 of an inch, let's see if I can do this. So that's a pretty big zoom. 1/8 of an inch. So this, here's an inch right here, right? From 2 to 3, this is an inch. 1/8 is this much. It's right from there to there. Can you see that? That's 1/8 of an inch. And so every 1/8 on the drawing represents a full foot in real life. And that's called a scale. So if I did this, this would be this wall. I don't know if this is going to work. We'll try it though. This wall right here. So every 1/8 of an inch represents a foot. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, what's that? 13, 12. I think I just lost count. This is 8 feet, 9, 10, 11, 12, 13, about, wow, that did work. 13 feet in real life, which is what the number's saying here. Okay, that's cool. So 1/8 of an inch represents a foot in real life. That's the idea of scale. So let's try to do some problems with these. Okay. Ratios and proportions, scale drawings, and scale factors. We're going to do this with proportions again. So set up your proportions, or set up your fractions. Let's say set up your fractions and solve, and just stay consistent. All right. Steve made a drawing of a city park. The scale he used was 1 millimeter is equal to 5 meters. Why is this getting dark? Can I make this brighter? What's going on with this? Let's just keep going. Okay, hopefully you can read this. So what we're going to do, let's go with millimeters over meters. That's how we're going to set this thing up. So 1 millimeter is to 5 meters. And coming down here, in the drawing, the soccer field is 12 millimeters over the actual one. Cross multiply, 60 equals x. So it's 60 meters in real life. On a public transportation map, 2 stations are 8 inches apart, whereas in real life, the distance between them is 2 miles. What is the map's scale? Write your answer in simplest form using whole numbers. Well, let's go again. Let's go with inches over miles. So 8 inches to 2 miles. Excuse me. And now we need to simplify this down so that we have a 1 somewhere. Wouldn't this be the same thing as 4 over 1? So 4 inches is 1 mile. I'll try one final one here, and then I'll try to figure out why my document camera is so blue looking. Try to take that off. It's just dark, and I can't lighten it up. I do not understand this right now. Okay. The Bellevue Convention Center is 10 inches away from the airport on a city map. The map uses a scale of 2 inches to 1 mile. So 2 inches to 1 mile, right? Inches to miles is the same thing as 10 inches to x miles. 10 equals 2x. X equals 5. Okay, that's it. Thanks for watching. It's kind of trippy. Doesn't it look weird? Is it just me? Doesn't this look really dark? What's my room look like right now? I don't know. Maybe I'm just losing it. Hey, thanks for watching. Bye-bye.